Hi 8th grade, this is Miss B with lesson 3.7. We are spending our second day on rotations, which is the third type of transformation we've learned so far. And our I can for today is I can rotate a polygon on the coordinate plane given a direction and the number of degrees. So a new vocab word for today that you might not have seen before is polygon. A polygon is just a shape with 3 or more sides. So today we're going to be rotating actual shapes in the coordinate plane. Let's take a look at example 1 on your handout, where we are asked to rotate triangle ABC 90 degrees counterclockwise about the origin. So one thing to think about before we even identify our points is which quadrant this triangle ABC is going to end up in if we're rotating 90 degrees counterclockwise. So remember from yesterday's lesson, counterclockwise means that we are turning or rotating our image to the left. And if we are rotating 90 degrees counterclockwise, we are only moving this image one quadrant. So it should land somewhere inside the second quadrant. So let's go on ahead with step 1 and identify the coordinates of the pre-image. So we have coordinate A at 1, 3. We have point B at 5, 9. And point C at 1, 9. Okay, so we are done with step 1 for rotations, and that's to identify the coordinates of the pre-image. The next thing you're going to do is take a look at what the new image will look like if we were to rotate 90 degrees to the left. And the way that we're going to do that is by actually turning our paper, our entire handout, 90 degrees counterclockwise. So your handout right now would be facing right side up, which is the image on the left. And what you're going to do is turn it 90 degrees to the left, or one turn to the left. So your image should end up looking just like that. So what's really cool about what happens when we turn our paper, the way that you have to think about the coordinate plane that you are looking at is that it's right side up. So ignore everything else on your handout. Pretend that this table here isn't even there. And this is your new x-axis, and this is your new y-axis. So we're imagining that even after turning our paper, that the coordinate plane is right side up. Look at where the triangle ended up in now. It's in the second quadrant, just like we had said it would be if we were rotating 90 degrees counterclockwise. And the coordinates for A, B, and C in this graph are really the coordinates for A prime, B prime, and C prime. So step 3 is going to be for us to identify the points that are in this second quadrant. So while your paper is turned sideways, and it doesn't matter if you write A prime, B prime, and C prime sideways, what's going to be important is when we actually plot these points on our graph. So while it's sideways, find any empty space near your graph, and we're going to identify A prime, B prime, and C prime, which is really the image that we're looking at once again. So A prime is now at -3 and +1. B prime is at -9 and +5. And C prime is at -9, +1. And the final step that you're going to take in identifying the coordinates of the rotation is actually plotting it in your coordinate plane. So for step 4, you are turning your paper right side up and plot and label A prime, B prime, and C prime. And what you end up with is this blue triangle in the second quadrant, and it's been rotated 90 degrees counterclockwise. So to talk a little bit about the table that you see at the top of your handout. we can have different rules or different coordinate rules for each type of rotation that we're doing. So one thing to keep in mind is that these rules are given to you in the counterclockwise position, each and every single one of them. But remember when we discussed yesterday, if you are ever told that you are going in a clockwise direction, the equivalent of going 90 degrees counterclockwise is to go 270 degrees clockwise, the opposite way. Rotating 180 degrees counterclockwise is the same as rotating 180 degrees clockwise. And finally, rotating 270 degrees counterclockwise is the same as rotating 90 degrees clockwise. So anyway, back to our example. When we are rotating 90 degrees counterclockwise, as we are in example 1, the rule that we would be applying is this first one right here, that every x and y value, the new coordinate would be to take the opposite of y as our new x coordinate, and the x value in the original point would be our new y value. So let's take a look at how that would look for example number 1. So again, the rule that we are using is that every x and y, our new x value is going to be the opposite of whatever the y value is. So in point A, since our y value is positive 3, our new x value for A prime is going to be the opposite of that, which is a negative 3. And our new y value for A prime is whatever x was in the previous example, or in the pre-image. So let's do the same for B prime and C prime. So B, we have a positive 9 as our y value, so our new x value is going to be a negative 9. And our new y value is going to be the x value for B, which is 5. And finally, C prime is going to be at negative 9 and positive 1. So this is just a different way that we can identify what the new coordinates are for our image. So in the remainder of the classwork, you may either choose to rotate your paper, just like we did when I first showed you how to rotate an image, or you can use the coordinate rules. Either way, you must, for full class credit, identify the coordinates of your pre-image and of your image. So for full class credit today, you are expected to complete the rest of this handout, which is Station 1, Performing Rotations. And homework for tonight is going to be to complete Station 2. So the sooner it takes you to get through Station 1, you may begin your homework for the night. And be very careful when you're asked to rotate clockwise or counterclockwise. You will get completely different images based on your degree rotation and the direction that you're asked to rotate. Good luck. See you next time.